This is the review for Module 17 using similar triangles. Math 2. Let's begin with number 1. In number 1, they're asking you to play something like Simon Says. They said EC, on the other side it would be ED. On the first side they said CA, on the other side it would be DB. Next they did EC and EA, so it would be ED and EB. On the next one, if you follow along, it would be EB, which is this whole side, and ED. So on the other side, it would be EA and EC. On this last piece, they did DB and then EB. So now they would do CA and EA. And the fractions would look like this. Number 2. On number 2, they're testing you whether you know and understand transformations. So this is a transformation, which is called a translation. Now, this is an isometry, so that means it will not change in size. But our second transformation here is a dilation. That means it will change in size, and so the only one we're concerned with here is our dilation, because that means that that's what's going to cause for our shape to change size. In our problem, they didn't give us a triangle, so we have to draw our own triangles. So as you can see here, I drew ABC and LMN, and they're telling us on our problem that ABC is actually mapping to LMN. Now, the only thing that's going to make something change size here is the dilation. So AB is 9. And according to our dilation, we're supposed to take that number and multiply it by 3. So if I take that number and multiply by 3, that would mean that this segment here, LM, would equal to whatever 9 times 3 is. And so that means that LM is actually 27. And that's how I'm able to find it. For problems 3 through 4, we have to use the diagram below, which is triangle DBC and YXW. On problem number 3, they're asking us what series or sequence of transformations maps WXY to BCD. So that means WXY is our pre-image and BCD will be our image. So we'll need to come over to our diagram again and take a look at that. So from marking the diagram, WXY is our pre-image and DBC is our image, which means that our pre-image, our P, happens first. And our image happens second. Our job here is to find out what caused P to get to I. The first transformation is going to be a reflection across the x-axis. So as you can see here, I have reflected triangle the YXW across the x-axis here. I use the x-axis, and so the letter CX was 1 unit away from the x-axis. So if I move 1 unit up from the x-axis, I end up at x prime. And the W was 1, 2, 3 spaces away from the x-axis. So if I start from the x-axis and move up 1, 2, 3 spaces, I end up with W prime. Same thing with my Y. I was 1 space away from the x-axis. So if I move up from the x-axis up 1 space, I end up at Y prime. So now my green triangle has been my first sequence in the transformation. So coming back to my problem and getting ready to write my sequence of similarity transformations, I started off with my original point. So every point has an x and a y. And after I moved it across my x-axis, the sign that changes is my y. Because my x's aren't actually moving, it's only being flipped around and the signs on the y are changing. So that explains my reflection across the x-axis. Now I have to go back to my shape so that I can do the last transformation. I can see here on my shape that the triangle DBC is much bigger than my green triangle y prime w prime x prime. So that must be a dilation. So I'm going to check my scale factors. The measurement from C to D is 8 units. So this here is 8 units. The measurement from x prime to y prime, so from x prime to y prime, is 4 units. The scale factor is done by doing image over pre-image. And in this case, my image is still my triangle DBC, which is the large triangle. That's still my image. My pre-image is my green triangle. In this case, that's my pre-image because I haven't done the dilation yet. So this is my beginning part. Once I'm done with my dilation, it will turn into the large triangle. So that's the image. So the image is 8 units and the pre-image is 4 units. So once I divide, I find out that my scale factor is a 2. I should check all my scale factors. In this case, it's 1, 2, 3, 4 units divided by 2, which is also 2 again. And if I did the distance formula from B to D, also from W prime to Y prime, I'd find out that that's also 2. So that means that my shape is growing by a scale factor of 2. So coming back to my actual problem, I'm going to come back and do my end result here, which is my dilation. So I'm going to take my 2x, I'm going to multiply my x's by 2, which is the scale factor, and I'm going to do the same thing to my y's, and that shows a dilation. That means it's grown. It grew by a factor of 2. The coordinate notation for each transformation, so for my reflection, would be x and negative y. So this is for my reflection. And for my dilation would be x comma y and 2x comma 2y, which means I'm multiplying each one by 2. For problem number 5, they're asking you to find hj, which I have marked in green. The segment marked in red is actually half the size of the segment marked in green. That means that fi is equal to half the size of hi. If we substitute the numbers, we'll be able to solve this equation. This means that if I take fi, which is 2x plus 20, I can substitute it here, and that's what it looks like. If I know hj is equal to 6x plus 6, then I can substitute it in for hj, and this is what that looks like. Once you've set up the equation, you can solve the equation. Okay, so 2x plus 20 equals half of 6, which is 3x, and half of 6 again is 3. Moving the 2x to the other side turns it negative 2x, and moving the 3 to the other side turns it into a negative 3. So 3x minus 2x becomes x, and that means x equals 17 because 20 minus 3 is 17. So your goal was to find hj. hj in the picture is 6x plus 6. So I'm going to write hj equals 6x plus 6. I know now that x is equal to 17, so I can substitute the 17 in for the x. So 6 times 17 plus 6 is equal to 108. Problem number 6, you have two triangles, and you know that the person is 5 feet tall, and you know that he casts a shadow of 8 feet. And you also know that the building casts a shadow of 40, but what you don't know is the height of the building. So now you can set up two fractions, and that create a proportion. So x over 40 equals 5 over 8. Now you can cross multiply and solve. 8 times x equals 8 times x equals 40 times 5. After multiplying, then you will divide by 8, and that means x is equal to 25. So that means the height of the building is 25 feet. That concludes page 1 of your review. Problem number 7, you're trying to find which answer is not true. So our first part is saying that KL is parallel to MN. In order to find out if KL is parallel to MN, we need to see if the proportion OK over KM is equal to OL over LN, if that proportion is true. So I set up my proportion. 349 over 349 is equal to 421 over 421. And I find out that this is true because 349 over 349 is the same as 1. And 421 over 421 is also 1. So that means A is true. Well, that's not our answer, but A is true. Now, KL is equal to 2 times the size of MN. So basically, B is saying that if I take MN and I multiply by 2, it should be equal to the size of KL. Well, if I take MN and I double it in size, multiply by 2, it's going to get a lot bigger. And that's definitely not the size of KL. So this is false. I'm going to keep checking so you can understand both, all of them. So MN is equal to 2 times the size of KL. So MN is double the size of KL. Since these lines are parallel, because we found out in part A that lines are parallel, then that means that KL is a mid-segment, which means that it is half the size of MN, or double. If I double 429, that'll be the size of MN. So this is true. And I was looking for the answer that was not true. So the only answer that's not true is B. For problem number 8, MN is equal to 2 times the size of KL, which equals 2 times 429, which equals 858. On problem number 9, the main triangle has a right angle at D, and that would mean that this red section here would be my extremes. So the side that's closest to DG would be GF, so that's one of my extremes. So the other extreme would be the whole entire side, the red side, which is GE, and they already have that. So the answer to this problem is GF. Now, if I were to use that for problem number 10, then I would have 1.5 over DE dg equals dg over ge, which is 5, because they're giving that to you. So if you cross multiply, you would end up with dg squared equals 7.5. So to remove the square, you'd have the square root, so that would mean that dg equals the square root of 7.5, or approximately 2.74. To find the geometric mean of 2 and 32, we would need to multiply them and take their square root. So that's the square root of 64. And the square root of 64 is actually the number 8. So 8 becomes the geometric mean. Number 12, 3 times 75 is 225. So if we take the square root of 225, we end up with the number 15 as the geometric mean. For number 13, if we multiply 6 times 42, we end up with 252. So if you take the square root of 252, it does not come out as a whole number. So we're going to need to split up the number 252 by doing prime factorization. So I took the number 252, I divided by 2, ended up with 126, divided by 2 again, ended up with 63. I couldn't divide by 2 anymore since the number does not end in an even number. So I divided by 3. 3 goes into 6 twice, and 3 goes into 3 once, so I got 21. And 21 can also be divided by 3, so I divided by 3 and I ended up with 7. So now what I want to do is look at the outer numbers here. I want to see if I have any pairs. So I have a pair of 2's, and I also have a pair of 3's. But 7 is not a pair, so we're going to leave that off to the side. Okay, so now when I take the numbers out, they end up being a 2 times a 3, and then the square root of the 7. So you can see I took out the 2, and I took out a 3, but the red 7 stayed in the radical. So if I multiply the green with the yellow, I end up with 6 square root of 7. And that is my answer for the geometric mean. On number 14, that's very similar to our building problem earlier. We do not know the height of the tree. But if we turn these into triangles, now we have similar triangles. And so now you can find the height of the tree by using proportions. So we are going to set up a proportion. X over 65 equals 5.6 over 8.1. When you cross multiply, you end up with 8.1 x equals to 364. And if I divide by 8.1, I find out that x is equal to 44.94. So that means that the tree's height, the tree is 44.94 feet tall. Okay, in problem number 15, 16, and 17, I'm responsible for finding x, y, and z. Now you can see that I marked the right angle in red. Across from the red angle, you have your green and your purple. And the means, so the green and the purple would become your extremes, but the means would be your 8, your y, and your z. Now I want to find out which mean actually has a number, and the only one that has a number is the 8, which is not the middle. So to set up my proportions, I would have to use the 8 as my means, and the portion here that is closest to the 8, so the one closest to the 8 is the 4. And I also have to use the entire length of my hypotenuse, which is OM, which will end up being x plus 4. So your setup should look like this. my two means, which is my 8, and the one that's closest to the 8, which is the 4, is my extreme, and the entire length, which would be the x plus the 4. Now I need to cross multiply. Should look like this. So 4 times x plus 4 equals 8 times 8. Now you would need to distribute the 4. After you're done distributing, it will look like this, and you need to subtract the 16. So now 4x equals 48, and I need to divide by 4. That would mean that x is equal to 12. Now that I know that x is equal to 12, I can put 12 in my picture. Now I need to set up for y. So this time my mean is y, and my extreme, since I'm using the middle, are just my two numbers, which is the 12 and the 4. If I cross multiply, I end up with y squared is equal to 12 times 4, which is y squared is equal to 48. If I break down my radical of 48, I'm going to find out that I have a pair of 2's, a pair of 2's, and a 3. So this will be 2 times 2, which is 4, and the square root of 3. So my answer for y is y equals 4 square root of 3. Last, I need to set up for z. So z becomes my mean this time, and my extremes will be the number that's closest to z, which is 12, and the entire length, which is 16. So I cross multiplied 12 times 16, and z times z becomes 6z squared. And I get rid of the z squared by square rooting, but I also change the 12 into 4 times 3. Now I know that 4 has a square root, and I also know that 16 has a square root, and the square root of 4 is 2. The square root of 16 is 8. 2 times 8 is 16. So my answer to my problem for z is 16. Excuse me, that's not correct. Square root of 16 is not 8. The square root of 16 is 4. So 2 times 4 is 8. So my answer for z is 8 square root of 3. And now I have all three variables. This concludes your second page of your review. On number 18, they're asking us which information would be enough to prove that the triangles are similar. Well, our choices to prove that triangles are similar are angle, angle, side, angle, side, or side, side, side. Now, in this case, we have P congruent to A, and that would make two angles. So that is enough for me to prove that the triangles are similar. On the other hand, PZ and AM, if I were to make those congruent, that would not be enough information, because in order for me to use side angle side, I would be needing MH and FZ. And the reason for that would be because I would need side, angle, side. And here I would need also side, angle, side. Now the last thing for us to check is angle M and angle F. Well, angle M cannot be marked with 2 marks, while angle F is marked with 1, so I really can't use that. So pretty much the letter A is our answer. Okay, in problem number 19, we're looking for the length of AB. We'll just call that X. And I can set up a proportion. So I could say X over 40 because they are in the same position. So x over 40. And I'm going to come back to this triangle. The next number would be 10. And 50 is the one that's matching with it. So the other side would be 10 over 50. Now all we need to do is cross multiply. So we end up with 50x equals 400, which that means x equals 8. And that would mean that AB, which is what we were looking for, is also 8. Your first move on a problem like this should be for you to put all the numbers in the correct order. Next would be for you to count them. So I counted 14, and I counted 14 on the numbers I wrote also, which would mean that half of 14 is 7. So if you count off 7 numbers, 1, 2, 3, 4, 5, 6, 7, that'll help you find your middle section. So for me, my middle section is right after this number. So from here down and from here up. My first number is 15.2. So my minimum is 15.2. My maximum is 29. And my median would be between 21.1 and 21.5, which means I need to add them together and divide by 2. Once I divided, I ended up with my median being 21.3. For my quartile 1, I end up finding out that the top part of my data, which is all of this, it has 7 numbers. And there is a middle number in between because I have 1, 2, 3, and 1, 2, 3 towards the top, but the middle number is 18. So that becomes my first quartile. My second quartile is my median, and my third quartile is found in the top part of my data. So again, I have 7 numbers, so that means I have 1, 2, 3. And if I count 1, 2, 3 from the back, and then I also have 27.2 in the middle. So my quartile 3 is 27.2. Now that's enough numbers for me to graph my box plot. So I set up a number line from 15 all the way to 30, going by ones, and I'm ready to use all my numbers. So as you can see, I put in my minimum, my maximum, my quartile 1, my quartile 3, and my median. Now I'm ready to make my line all the way across. And I need to make a box around the middle numbers with the line through the median. That's my box plot. For problem number 10, your first move should be for you to put the numbers in order. So here I put M in order, 32, 33, 35, 35, 45, 46, 48, 49, 15, 50. I found the minimum, the maximum, the median, and the quartile 1 and quartile 3. I did the same thing for A up here. So I have them all in order, and I have all my numbers, my important numbers. I went ahead and I plotted all the numbers, and I did my box plot. And now I'm ready to compare the medians and interquartile ranges of the quiz scores for the morning class and quiz scores for the afternoon class. So after calculating, we find out that the median scores for the quizzes of the morning class are lower, slightly lower than for the afternoon class, and in the interquartile ranges as well. The interquartile range is a spread of 11, and the interquartile range for the afternoon class is a spread of 14. So now we can compare. This concludes your review. Hope this helps. Good luck tomorrow.